Hi students, today we are going to discuss the second part of polarity of molecule and percentage ionic character. In this video we will discuss some questions that is very important in NEET, JEE and that type of competitive exams. Okay, so first question, here we have some molecules HF, HCl, HBr, HI. Arrange these molecules in the increasing order of their polarity, okay, or dipole moment. So we know that, listen here, we know that dipole moment mu is equal to q into distance. That is, q is the charge, this is the distance between or bond length, distance between two atoms or bond length. So depends on charge, that is dipole moment depends on charge and distance. Okay, we know that higher charge for electronegativity for what? Fluorine, then chlorine, then bromine, then iodine. But the bond length, that is distance, higher for what? Iodine. Okay, so here will be the bond length more. Dipole moment is the product of what? Charge and distance. Dipole moment എന്ന് പറഞ്ഞാൽ ചാർജിന്റെയും ഡിസ്റ്റൻസിന്റെയും എന്താണ്? പ്രൊഡക്റ്റ് ആണ്. ചാർജ് ഏറ്റവും കൂടുതൽ ആർക്കാണ്? ഫ്ലൂറിൻ ആണ്. ഡിസ്റ്റൻസ് ബോണ്ട് ലെങ്ത് ഏറ്റവും കൂടുതൽ HI ക്കാണ്. അപ്പോൾ ഡിസ്റ്റൻസ് വെച്ച് നോക്കുമ്പോൾ ആരായിരിക്കും മോർ പോളാർ? HI ആയിരിക്കും. ചാർജ് വെച്ച് നോക്കുമ്പോൾ ഏതാണ്? HF ആയിരിക്കും. പക്ഷേ ഡിസിഷൻ ആൾവേസ് ടേക്കൺ ബേസ്ഡ് ഓൺ ചാർജ്. Decision always taken based on charge of the molecule. Okay, so but exceptions are there. Exception we will discuss later. So higher charge for what? HF, then chlorine, then HBr, then HI. So the order of the dipole moment, what? HF greater than HCl, greater than HBr, greater than HI. This is the order of polarity or dipole moment. That is the first question. Now second question, coming to the second question, in these two compounds, that is trans, this is what? Cis. Okay, these two compounds, which is more polar? So this compound we can take first is trans compound we can take. Listen here, Cl here, H. Which one have higher polarity or higher electronegativity? Chlorine. So this have partial negative, this have partial negative. Then carbon and hydrogen, which one have? Carbon have high electronegativity, so this one have partial positive, here partial positive. Always the direction of the dipole moment always from what? Positive to negative. So this dipole in this way, here it is in this way. These two cancel. Now this is what? Positive to negative. This is, so these two cancel. So dipole moment mu is equal to 0. So this molecule is what? Non-polar molecule. Non-polar molecule. Now we can take cis isomer. Cis isomer, listen here. What is cis isomer? Cl. Here it is what? H. Okay. Now we know that this is partial negative, partial positive. Okay, now what is the direction? This is the direction, this is the direction, here it is, this is the direction, this is the direction. See, these two are what? Same direction, these two are what? Same direction. So it is what? Two vectors, that is this vector adding, we will getting a resultant vector. Now this and this. Okay, so these are the two vectors, the resultant will be what? This one. So polarity, that is mu is not equal to 0, so this molecule is what? Polar. It means this is what? Polar. Okay, that means cis isomer is polar. Cis isomer is polar than what? Trans. Cis isomer is polar than trans. Trans here it is what? Non-polar. In some case cis is what? More polar, trans is what? Less polar. Okay, so here it is cis polar than trans. Now another example we can take. See, third example. In that third example, see, third example, C double bond C H. Here it is what? Ca3. here C double bond, CH3 here. This is what trans, this is what cis. Ca3, this is C, both are C. So sp2 carbon is, this is sp2 carbon. sp2 carbon is more electronegative, therefore it has what? Partial negative, this one partial positive. Partial negative, partial positive, H positive. So this is this direction, this direction. Okay. Positive to negative, dipole moment positive to negative, positive to negative. These two will cancel, these two will cancel. Mu is equal to 0, non-polar. So trans is what? Non-polar. In former case also, trans is what? Non-polar. Now here, see, Ca3, see, sp2 carbon, sp carbon. This is more electronegative. So direction, this one. Okay. Now this one is what? Here. This one. This and this will not cancel because the magnitude is different. This is Cc bond, this is Ch bond. This is what? Cc bond, this is what? Ch bond. So the magnitude of this dipole moment, that is Ch bond dipole moment, because the electronegativity of hydrogen is what? Very less as compared to other atoms. That's why this dipole moment we can ignore or neglect. So we can take these two. By taking these two, we will get what? Resultant dipole moment what? Down. So this is what? Mu is not equal to 0. Therefore, this molecule is what? Polar. Again here cis is polar than trans. Cis is polar than trans, but it is not always correct. In some molecule, some exceptions are there that we will discuss. In many books, it is written that what? Cis always what? More polar than what? Trans. But some exceptions are there. We will discuss that. Okay. പല ബുക്കുകളിലും എന്താണ് എഴുതി വെച്ചിട്ടുണ്ട് സിസ് ഈസ് മോർ പോളാർ ദാൻ ട്രാൻസ് എന്ന്. പക്ഷേ എല്ലായ്പ്പോഴും എന്തല്ല, ശരിയല്ല. ചില മോളിക്യൂളിൽ എന്താണ് ട്രാൻസ് ഈസ് മോർ പോളാർ ദാൻ സിസ്. ഓക്കെ. സോ വി ക്യാൻ കം ടു ദ നെക്സ്റ്റ് എക്സാമ്പിൾ. നെക്സ്റ്റ് എക്സാമ്പിൾ, ഫോർത്ത് എക്സാമ്പിൾ. Coming to the fourth example. Fourth example, we can see CH3, C double bond, H, Cl, H. CH3, Cl, H, H. This is what? Trans. H opposite, H and H opposite. Here H same side. So it is what? Cis. Now let us see. Here what? This is sp2, this is sp carbon. So partial positive, partial negative. Here it is what? Cl more electronegative. So this one is what? Partial positive. Now as compared to hydrogen and carbon, when we compare, which one is more electronegative? Carbon is more electronegative. So this one is what? Partial positive. So this direction will be here. Again here it is what? Like this. Now what is the direction of dipole moment? This is the direction of dipole moment, this is the direction of dipole moment. These two will cancel. Okay, but here what is the direction? This is the direction of dipole moment, this is the direction of dipole moment. Two dipoles. What is the angle here? Angle 0. Cos 0 is what? 1. So vector addition, angle 0, resultant will be maximum. So here the maximum dipole moment mu is not equal to 0. It is what? Polar. Now in this case, see, this is what? Ca3, sp2 carbon. So dipole moment in this way. Here chlorine is more electronegative. This is the dipole moment. Okay. Now this we can ignore because I told you that the dipole moment due to CH bond is very less. So we can ignore it or neglect it. Now see, two vectors are there. One vector in this direction and the vector in this direction. Okay, so that is in this direction. So we can just slide this vector. So what happens if you slide this vector in this way? It will be what? Like this. Okay, so angle is what? Not 0, more than 0. When the angle increases, cos value what? Decreases. Cos 0 is what? 1. Okay, suppose if it is what? Suppose 60 degree, the value of cos what? Increases. So sorry, value of cos what? Decreases. That's why the resultant will be what? Less. So resultant is less. Here resultant is maximum. So this one is also mu not equal to 0, polar. But see, remember, don't forget, this is what cis, this is what trans. Both are polar. Which one is more polar? Trans is more polar because angle is what? 0. Okay, so trans is more polar than cis. It is what? Exception. In former example, we said what? Trans is what? Less polar as compared to what? Cis. But here it is what? Trans is more polar as compared to what? Cis isomer. അതുകൊണ്ട് ഈ എക്സാമ്പിളിൽ ഏതാണ് മോർ പോളാർ? ട്രാൻസ് കൂടുതൽ പോളാറാണ് ഇതിനേക്കാളും സിസിനേക്കാളും. ഇവിടെ ആംഗിൾ എന്താണ്? 0 ആണ്. കോസ് 0 എന്താണ്? 1 ആണ്. ഓക്കെ, അപ്പോൾ റിസൾട്ടൻ്റ് വിൽ ബി മാക്സിമം. Resultant will be maximum. But in this case, vector addition, angle is greater than 0, so the resultant decreases. When angle increases, vector addition, the resultant decreases. So trans isomer is more polar than cis isomer in this case. Now next example, see the fifth example. Listen here. In fifth example, what happens? Fifth example, what happens? Fifth example we can explain here. See, this is C2H5, this is what? Ca3. Now this is sp carbon, so sp3 carbon, this is sp2 carbon. So which is more electronegative? Sp2 carbon is more electronegative. So this is partial positive, partial negative. Here it is what? Sp3 carbon, so partial positive, partial negative. So this is the direction, this is the direction. So this is the direction, this is the direction. H cancel because opposite. These two will not cancel. Why? Because it is Ca3, this is C2H5. So the magnitude will be different. Somewhat cancel, partially cancelling but not fully. So this mu is not equal to 0. Therefore this molecule is what? Polar. So here trans is what? Polar. In former example, trans was what? Non-polar. Mu was 0. But here it is what? Mu is not is equal to 0 because here it is C2H5, here it is what? Ca3. The magnitude is different, so they are not cancelling each other. Now here cis isomer, here what? Partial positive, partial negative, partial positive, partial negative. This I told you that we can neglect it. So one dipole in this direction, one dipole in this direction. Resultant one dipole in this direction, one dipole in this direction. Okay, what we can do? We can what? Slide this here, this here. Just slide this here. Sliding, this is sliding here. So resultant will be what? This vector is sliding to this vector is sliding to here. So the resultant will be what? Downward. So net dipole moment is not equal to 0. Mu not equal to 0. Polar. Which one is more polar? This is more polar. Why? Because here it is what? Downward resulting. Here it is what? Partially cancelling. So in this case, trans is less polar as compared to what? Cis. Cis is what? More polar. Here cis more polar, trans less polar. Here which is more polar? Trans more polar, cis less polar. Here trans non-polar, cis polar. In this case also trans non-polar, cis polar. Next we are coming to few more examples. See here 3 molecules are question number 1. 3 molecules are there. 1,2-dichlorobenzene, 1,3-dichlorobenzene, 1,4-dichlorobenzene. Arrange this molecule in the decreasing order of their dipole moment or polarity. How we can discuss? Listen here. See here, this is partial negative, this is partial negative, this is partial positive. So one dipole in this direction, one dipole in this direction. Here it is what? Dipole here. In this example, opposite. Okay, so the 3 dipoles. First dipole angle is about 60 degree. Second case angle is about 120 degree. Now third, opposite cancel each other. It's okay, opposite cancel each other. Here it is what? 60 degree. here 120. Now we know that net dipole moment, suppose this is mu1, this is mu2, then mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Okay, I told you that when the angle increases, the value of cos theta decreases. So we can take first example, theta is 60, cos 60 is what, 1 by 2. Now mu1, this both dipole moment are equal magnitude, so mu1 and mu2 are mu, we can take as mu. So if you substitute here mu net, you will get what, mu net you will get what, root 3 mu, root 3 mu. Here again what, cos value decreases, angle increases, so the value cos 120 again decreases, so you will get what, lower dipole moment. Here what, two dipoles are in opposite direction, they cancel with each other. ഈ ലാസ്റ്റ് എക്സാമ്പിളിൽ രണ്ട് dipole moment opposite directionലാണ്, അതുകൊണ്ട് ഇതും cancel ചെയ്യും. അതുകൊണ്ട് ഇതിന്റെ dipole moment ഓർഡർ ഇതാണ്, 1,2 ഡൈക്ലോറോ is greater than 1,3 greater than 1,4. ഓക്കെ, ഇനി രണ്ടാമത്തെ ക്വസ്റ്റ്യൻ. ഈ രണ്ടാമത്തെ ക്വസ്റ്റ്യനിൽ ഏതാണ് അല്ലെങ്കിൽ ഏതൊക്കെയാണ് ഈ മോളിക്യൂളിൽ ഈ തന്നിരിക്കുന്ന 4 എക്സാമ്പിളിൽ നോൺ പോളാർ എന്നതാണ്. നോൺ പോളാർ ആയിട്ടുള്ള മോളിക്യൂൾ ഏതൊക്കെയാണ് എന്നുള്ളതാണ്. ഓക്കെ, ഒന്ന് നമ്മൾ നേരത്തെ പറഞ്ഞു, ഇത് നോൺ പോളാർ ആണ്. ദിസ് വൺ ഈസ് വാട്ട്, നോൺ പോളാർ, സെയിം ഹിയർ ഇറ്റ് ഈസ് വാട്ട്, നോൺ പോളാർ. സോ ദിസ് വൺ mu is equal to 0, നോൺ പോളാർ, നോ ഡൗട്ട്. ദിസ് വൺ ആൻഡ് ദിസ് വൺ ഈസ് വാട്ട്, പോളാർ. ഓക്കെ, നോ ഡൗട്ട്. Now what about this one? Here dipole moment, this dipole in this direction, will they cancel each other? No, because this is not benzene ring, it is cyclohexane. Cyclohexane is not what, planar, it is not planar. So these two dipole moments are not acting what, opposite to each other, because they are in different shape. You know that conformation of what, cyclohexane boat, chair, twisted boat, okay, half chair, different what structures are there. It is not a plane, it is not a planar molecule, therefore these two are not exactly opposite, so they will not fully cancel. So this one is what, polar, not non-polar. So mu is what, not equal to 0, it is polar. This one polar, this one polar, this one polar. This is the only example that is what, non-polar. That is second question. Next, third question. See, third question, arrange these three molecules in the decreasing order of their polarity. How we can arrange? I told you that dipole moment depends on two factors, that is charge and distance. Decision always taken based on charge. Fluorine is more electronegative than oxygen, which is more electronegative than nitrogen. So partial negative charge more for what, fluorine, then oxygen, then nitrogen. So which one will be more polar? HF is more polar than H2O, more polar than ammonia. Now in this case also, oxygen, sulfur, selenium, all these three atoms, that is oxygen, sulfur and selenium belongs to 16th group, same group. Down the group, electronegativity decreases. So which is more electronegative? Oxygen is more electronegative, then sulfur, then selenium. Okay, so the polarity is what? We are determining the polarity based on what, electronegativity or charge. So which is higher electronegativity, oxygen. So H2O is more polar than H2S, which is more polar than H2SE. Okay, so this is what, polarity order. Now next example is an exception. I told you that the decision always taken based on what, charge, but some exceptions are there. Here exception, one example is coming, that is exception. Ca3F and Ca3Cl, that is chloromethane, fluoromethane, bromomethane and iodomethane. Okay, so based on the charge, which should be what, more polar, fluoromethane should be more polar than chloromethane, which is more polar than bromomethane, which is more polar than iodomethane. If you consider only the bond length or distance, which should be more polar, iodomethane, then bromomethane, then chloromethane, then fluoromethane. I told you that decision is made by based on what, charge, but here exception. Here the order is what? Chloromethane is more polar than fluoromethane, which is more polar than bromomethane, which is more polar than iodomethane. Reason is what? In this case, chloromethane distance is what? Very much higher than what? Fluoromethane. Okay, charge what? Decreases. Charge decreases as compared to what? Fluorine. Whatever decrease in the charge as compared to fluorine, in case of chlorine, more than that what increases? Distance increases. So dipole moment is what? Q into D. അതായത് ക്ലോറോമീഥേൻ്റെ കേസിൽ ഫ്ലൂറോമീഥേനെ അപേക്ഷിച്ചിട്ട് ഫ്ലൂറോമീഥേന് ക്ലോറോമീഥേനിലേക്ക് വരുമ്പോൾ ചാർജ് കുറയുന്നുണ്ടെങ്കിലും ആ കുറയുന്നതിനേക്കാളും കൂടുതൽ എന്ത് കൂടുന്നുണ്ട്? ഡിസ്റ്റൻസ് കൂടുന്നുണ്ട്. അപ്പോൾ ഡിസ്റ്റൻസ് നന്നായിട്ട് കൂടുന്നു, ചാർജ് കുറച്ച് കുറയുന്നു. അപ്പം മ്യൂ എന്താ ചെയ്യുക? കൂടുക ചെയ്യാം. എവിടെ? ഈ കേസിൽ. ഓക്കെ, നൗ in case of fluoromethane what? Charge increases, distance what? Decreases. As when we compare chloromethane and fluoromethane, Q what? Increases. Fluorine is more electronegative than chlorine, but the distance is very much less than what? Chloromethane. That's why here the product of Q and D will be what? Less as compared to what? Chloromethane. So the order is what? Chloromethane greater than fluoromethane, greater than bromomethane and iodomethane. From here onwards what? Again what I told you that based on charge we are determining which is what? More polar. Here an exception. Fluoromethane is not more polar than what? Chloromethane, but chloromethane is polar than fluoromethane. That is an exception. Remember that. Next example, yes, aldehyde. In this case, which is more polar? See, this is sp2 carbon, this is sp3 carbon, which is more electronegative, this one. So dipole moment this one, this side, then carbon and oxygen, which is more electronegative, oxygen is more electronegative than this one. All are acting same direction. Here, this one partial negative, this is two dipoles. CH bond is negligible as compared to here what? CC bond, CH bond is what? Negligible. Okay, now here what? Chlorine is more electronegative than what? Carbon. So dipole moment this way, this way, this way. So which will be more polar? This one will be more polar because all dipoles are acting in the same direction. Now this one will be more polar. Here what? Partially cancelling, CCl bond and CCl bond one side and a CO bond other side, partially cancelling. So this one will be least polar. So remember, aldehyde 3, ketone is more polar than aldehyde. Okay, clear? So coming to the next example. Okay, coming to the next example, this compound propanol, this compound prop 2 in 1 al, which is more polar, that we have to decide. Okay, see here double, single, double, resonance. Okay, that's why this bond shift here, this bond. Okay, so this bond get partial double bond, not fully double bond, partial double bond. So bond length increases. Partial double bond is what? Bond length greater than what? Full double bond. So this is what? Partial double bond because it is involved in resonance. So distance increases. Okay, now here there is no such resonance. So this is a full double bond. So here what? Distance what? Less. Dipole moment mu is equal to what? Q into D. Q is same in both cases, but distance here what? More because it is partial double bond. So this one will be more polar. Propan 2 in 1 al will be more polar than propanol. Okay, the reason distance is more. Now here in this second case, okay, see vinyl chloride, here what? Chloroethane, which is more polar. See, this lone pair can involve in resonance. So resonance partial double bond. Here there is no such resonance, it is single bond. Single bond distance is what? More. Here partial double bond distance will be what? Less. In this case, because of the resonance, what happens? Distance increases. Here, because of the resonance, what? Distance decreases, because it is what? Getting partial double bond character. Here it is what? Single bond. ഈ കേസിൽ ഇതിന് partial double bond character കിട്ടുന്നു. ഇവിടെ എന്താണ്? സിംഗിൾ ബോണ്ട് ആണ്. ഈ കേസിൽ ഇതിന് ഡബിൾ ബോണ്ട് ക്യാരക്ടർ പോയിട്ട് പാർഷ്യൽ ഡബിൾ ബോണ്ട് ക്യാരക്ടർ വരുന്നു. ഇവിടെ ഫുൾ ഡബിൾ ബോണ്ട് ആണ്. അതുകൊണ്ട് ഇവിടെ റെസൊണൻസ് കൊണ്ട് ബോണ്ട് ലെങ്ത് ഇൻക്രീസ് ചെയ്യുന്നു, ഇവിടെ റെസൊണൻസ് കൊണ്ട് ബോണ്ട് ലെങ്ത് ഡിക്രീസ് ചെയ്യുന്നു. അപ്പോ ആരാണ് മോർ പോളാർ? ഡിസ്റ്റൻസ് ഇൻക്രീസസ്. Distance increases. So this chloromethane will be more polar than this vinyl chloride. Okay, so this is an example. Now we have four molecule: chloromethane, dichloromethane, trichloromethane, CCl4. Which is more polar? We can discuss the structure. C, Cl, H, H tetrahedral. Okay, C polarity here, dipole moment upward. All are in same direction. Now CH2 Cl2, see here, Cl H dipole, here dipole, this dipole in this way, this dipole in this way, because chlorine is what? More electronegative. Chlorine is more electronegative. Next example comes, CH Cl H. See, next CCl4. This I told you last video. Central atom, all atoms are same and symmetric. Surrounding atoms are what? Similar and also symmetric. No lone pair. So this is what? Non-polar. See, here all are same direction. Here what? This one here, this one here. Resultant will be like this. So this will be what? Added. So this one will be more polar because all are same direction. This one will be what? Less as compared to this one. Here it is what? Partially cancelling. This and this partially cancelling. So this will be again less polar. This is non-polar. So the order of the polarity, this is the order of polarity. That is, chloromethane is more polar than dichloromethane, which is more polar than trichloromethane or chloroform, which is more polar than carbon tetrachloride or CCl4. This is the order of polarity. Okay, now we are going to discuss about the percentage ionic character. I told you that a covalent bond have some polarity or dipole moment, so it is not 100% covalent. It has some ionic character. Ionic bond also has some covalent character, that is explained by Fajan's rule, that we will discuss in another video. Okay, now covalent bond have some ionic character. What is the percentage of this ionic character? To calculate this percentage of this ionic character, we have an equation. That equation is what? Observed dipole moment or experimental dipole moment. That is, after conducting the experiment, what dipole moment we are getting, divided by theoretical dipole moment into 100. Okay, theoretical dipole moment, we are considering the molecule is fully ionic. That is, it has a +1 charge and a -1 charge. Okay, that is fully ionic, like NaCl. NaCl, we know that it has what? Na plus and Cl minus. So in theoretical dipole moment, we are considering it as what? Fully what? Ionic. Okay, so we are taking the charge of one electron. That is what? +1 or -1. We are taking only the magnitude. Okay, now it is can be calculated by the equation. This equation we can simplify like this: Q by E. Okay, simplification I am not giving, just this equation is enough. Q by E. Q is the charge, E is what? Charge of electron into 100. We can do an example, one problem. HF, suppose the bond length or distance between H and F is 1 angstrom. Then observed dipole moment, that will be given in question paper. Observed is what? 3.2 into 10 raised to -31 coulomb meter. What is the percentage ionic character? Okay, so we need what? Q, charge of electron we know, then we will get what? Percentage ionic character. So first of all, this is coulomb meter. So angstrom should be converted into what? Meter. So distance D is equal to 1 angstrom, means 1 into 10 raised to -10 meter. Okay, now mu observed is given. What is mu observed? Mu observed is equal to 3.2 into 10 raised to -31 coulomb meter. coulomb meter. This is equal to, according to our equation, mu is what? According to our equation, mu is equal to what? Q into D. That is Q into distance is what? 10 raised to minus 10 meter. We need what? Q. Then Q is equal to what? This divided by 10 raised to minus 10. Then Q is equal to 3.2 into 10 raised to minus 31 coulomb meter divided by 10 raised to minus 10 meter. Meter cancelled. Then 10 raised to minus 10 minus 31. Then it will be what? 3.2 into 10 raised to minus 21 coulomb. That is what? Q. Now we got what? Q. If you know the Q, we can calculate the percentage ionic character. How? Then percentage ionic character is equal to Q, 3.2 into 10 raised to minus 21 coulomb divided by charge of electron. We know that charge of electron is what? 1.6 into 10 raised to minus 19 coulomb into 100. Okay, so this we can cancel. This will be what? 3.2, 1.6, that is 2. Then 2 into 10 raised to minus 19, it will be what? 10 raised to minus 21 into 10 raised to 19 into 100. That is, this will be what? 21. Then this plus 21 and minus 21 cancelled, that is 2%. So the ionic character is what? 2%. That we will get. It's okay. So this is one problem. We can do one more problem. We can discuss another question. In that question, HCl, the bond length is what? 1.275 angstrom and mu observed is 1.03 dBi. So here listen, the observed dipole moment is given in dBi, not coulomb meter. Coulomb meter is the SI unit. It is not given in SI unit. So in such case, we have to take the charge, that is Q. That is, we know that percentage ionic character is what? Q by E. Okay, so charge we have to take in what? ESU. Okay, so Q in what? ESU and electrostatic unit, and distance what? In centimeter. Distance in centimeter. Okay, we know that 1 dBi is equal to 10 raised to minus 18 ESU centimeter. Similarly, charge of 1 electron, if you convert into electrostatic unit, it will be what? 4.8 into 10 raised to minus 10 ESU. So okay, now we can take charge. We know that mu is what? 1.03 dBi is equal to 1.03 into 10 raised to minus 18 ESU centimeter. That is what? Mu observed. So mu observed we got. Now we know that mu observed is equal to Q into distance. That is, Q is what? Charge. Q is what? Charge. Okay, so Q into distance is given what? 1.275 angstrom. Angstrom should be converted into centimeter. So if you convert into 10 meter, it will be what? Minus 10. If you convert into centimeter, it will be minus 8 centimeter. Okay, so this is what? Mu observed. Now distance we got, mu we know, that is what? 1.03, that is mu 03 into 10 raised to minus 18. Okay, now we have to find out what? Q. Q is equal to what? Q is equal to 1.03 into 10 raised to minus 18 divided by 1.275 into 10 raised to minus 8. Okay, so this is what? Centimeter. This one is what? ESU centimeter. Now centimeter cancelled, minus 8 cancelled, so you will get what? Okay, so you got what? Q is equal to 1.03 divided by 1.275 into 10 raised to minus 10 that you got. Okay. Now if you know the Q, percentage ionic character is what? Percentage ionic character Q by E. That is Q is equal to what? 1.03 divided by 1.275 into 10 raised to minus 10 divided by charge, electron charge. That should be converted into ESU, not in coulomb. So I told you that the charge of electron 1.6 into 10 raised to minus 19 coulomb. If you convert into ESU, it will be what? 4.2 into 10 raised to minus 10 ESU. Substitute here 4.8 into 10 raised to minus 10 ESU into what? 100. Here what? Into 100. Percentage into 100. Here also we have what? Into 100 percentage. Okay, so minus 10 cancelled. If you do this, you will get what? Percentage ionic character approximately what? 17%. So if the dipole moment is given in question paper in d by, you have to take the charge in ESU as well as distance in what? Centimeter. Distance in centimeter. Okay, then same equation Q by E into 100, we will get what? Percentage ionic character. So next video we can discuss what? Bond order and the trick to find out the bond order. Okay, we can see again in next video.